So here's our old robot platform. These robots are designed for research. They're fantastic, but they're frighteningly expensive. So I want to get robots to everyone. And the way to do that is to build this new platform. This is the Rice R1 mobile robot, and it is advanced enough for multi-robot research. It is robust enough for undergraduate and graduate education, and it is cheap enough for K-12 outreach. So these are robots that we want to get to everyone, and we want them to be as popular as scientific calculators.
So this is the wall of parts that we've slowly built up over time. So we have almost every single part that goes on one of these robots. We want to see all the lights flashing in the system to make sure every single light is working. The antennas are just like the way your phone works. We send information over the antenna, and everybody receives the same information. But their second form of communication is infrared. It's directional. So two robots are going to send IR information similar to the way a TV remote works.
The total parts count for this robot is right around 9 assembled parts once you have all the things put together. This robot is simple enough that we're going to offer it first as a kit form in the upcoming year so that anyone can go and order these things and build them at home, or build them in your lab, or build them in your school.
We put them through a class last semester of freshmen, and I was kind of the head TA, so I was responsible when all the robots had a problem, and I saw ones that I was almost certain were dropped in a pool of water at one point, and they still were able to work.
My work is on multi-robot systems. You can call them swarm robots. So I'm not interested in building one robot or two robots. I start to get interested when we talk about 100 or 100,000 robots. So in order for me to do that in my lab, I need to have a robot platform that is small enough and cheap enough for me to build at least hundreds of them.
They're following this blue robot right now. Everyone that is following the blue is lower than the blue right now. With following, it's a good way to have the robots navigate more complicated obstacles in a follow.
There are many applications for multi-robot systems. Recently, we just had an oil spill in the Gulf of Mexico, so it would be fantastic to have 1,000 little robots swimming around the Gulf, identifying where the oil actually went. Earthquakes. We've had earthquakes, we've had tornadoes, we've had tsunamis. Having robots that could penetrate the rubble pile of a building, look for survivors, identify is the power on, is the power off. These are things that robots can do far better than people can.
This is a flocking behavior. So their goal here is to actually just match each other's orientation. So there's no leader this time. So it's pretty much like just a cluster of robots that are all trying to make some sort of smart decision on what they want to do. And the goal of clustering is the even-numbered robots will turn red, and the odd number of robots will turn blue, and we'll see if we can get them to cluster. But they'll stay together in a cluster. I can try to separate one and say, stop clustering together. And eventually they'll all move towards that robot, and they'll form a new cluster.
Here's our 2003 design. It's a full, sophisticated research platform. Here's our 2012 design. It does almost the same stuff, except it's 1/10 the price. Rice University, the R1 mobile robot, robots for everyone.